Welcome to part 5 of this module. In this module, we'll be taking a look at FERN Wi-Fi Cracker. FERN is a wireless security auditing and attack tool that is written in pure Python and uses the Python QT GUI library. The program is theoretically able to crack the WEP, WPA, and WPS keys, and also run other network-based attacks on wireless and Ethernet-based networks. But all it really is a graphical tool for doing things that you've already seen done in this module so far. FERN is located under Applications, Wireless Attacks. We'll just click on it to load it. Now I say that this all works theoretically, and that is because whether or not FERN actually operates correctly seems to depend on its mood and maybe the weather. I've tested this tool on several different systems, so I've ruled out hardware problems. I haven't gone through the code line by line because quite honestly I don't use FERN for actual pen tests. But as near as I can determine, FERN just kind of works properly whenever it wants to, which isn't necessarily that often. So right away, we are greeted with a pretty simple graphical interface. If you've watched the prior videos in this module, nothing about this is going to be mysterious or require a lengthy explanation. But basically, in a nutshell, FERN does everything that you've seen so far, again in theory. You don't need to put your card into monitor mode or mess around with AeroDump-ng because all of that is actually built into FERN. It even allegedly changes your MAC address for you, although the bug with MAC changer still seems to apply on some systems. So I wouldn't trust that it is in fact working as intended until you test it yourself. We begin with FERN by selecting our interface device. In this case, it's going to be WLAN 1. And you can click the refresh button if you insert a USB device after loading FERN. And here we get the tooltip saying, to access the settings for the network scan preferences, double-click on any area of the main window. Scan for network button is used for scan for network based on the settings option of the settings dialog. Default is automated scan. Fake MAC address is always used. Okay, but it said nothing about the fact that you need your Wi-Fi card to be capable of injection for injection-based attacks to work, so maybe not the most useful tooltip ever. In any case, if we double-click on this screen, we can see that it is possible to set what channels we scan for. In other words, we can narrow that to a single channel from the drop-down menu if we want to. Again, this is exactly like using AeroDump from the command line, where if we don't specify a single channel, it'll just get everything in range. So now we're going to click Scan for Access Points. It's initializing, it'll take a second. And once it does, we'll see a number next to the Wi-Fi WPA, which tells us how many routers have been detected within range. You might also see a few pop up next to the Wi-Fi WEP button, although those are rare in this day and age, and few people are really still using WEP. If we let this go for a while, more than 8 should pop up, but I think 8 will be good enough. So I'm going to stop the scan by pressing the button again. And we're going to go into WPA. And this brings up a graphical readout of nearby access points. This is basically a prettier version of AeroDump-ng. I'll click on the old router I've been using for these demonstrations. It's still Sanjal. And here, we see the ESSID, BSSID or MAC, channel, power rating, and encryption style. We also see that it supports WPS, basically everything we'd see in AeroDump. From here, we can select the attack method. I'm going to pick WPS first just to demonstrate that contrary to the access point details, we will be told that Wi-Fi protected setup is not supported or distributed by the selected access point. This is what I mean about Fern being rather unreliable. But it's always worth trying the WPA attack first. As I mentioned in the Reaver video earlier in this module, although it is admittedly pretty rare that such a straightforward approach will actually provide results, it is much faster when it does work. So to begin, we need to give it a dictionary file for brute forcing. Assuming it successfully captures the handshake, Fern will immediately go to work to try to crack it. There are no fancy configuration methods here, as we saw in prior videos. You can't pipe in characters or curtail the min-max length of the password. This is a straight brute force cracker. We give it a word list file, and it will try every word in that file. So we click Browse. We're going to go to the desktop, and we'll give it this file, password. And of course I am cheating here. You see, it cracked the key earlier when I tested it, so it's displaying it. I'm going to go ahead and delete the key from the keybase so that this scan process plays out as if I'd never done it. And we'll try this again. Okay. Now, in a perfect world, we select our access point, which in this case is Sanjal. We select regular attack, and then we just click the Wi-Fi attack button. So it begins by probing the access point and launching deauthentication attacks. And Fern will now proceed to try to kick a client off the access point through these deauthentication attacks. Then it will grab the handshake when the client re-authenticates with the network. Well, that went rather quickly. Okay, well, that went faster than I expected. Basically what happened is Fern probed the access point. It found the target client, in this case the laptop, the junky laptop that I had connected to the junky router I'm using for this demonstration. It deauthenticated it with packet injection, similar to what you saw in the prior modules. It then captured the handshake when the client was bumped off the network and then re-authenticated automatically. Once it had the handshake, it began a brute force attack, reading off every password in the password file that we provided it. Now, of course, I cheated and put the correct password, Hanko20*, into that file to make sure that it would crack in a timely manner. I mean, we don't want to be here all day. And once it did that, it successfully cracked the password. It displayed it here, and we'll be able to find it in the keys database, which I will show you in a moment. I think it's also a good idea to point out here that even though the probe access point phase of this attack is supposed to provide you with this MAC address right here in a drag down menu form, it doesn't always work that way. You may end up having to use arrowdump-ng to get the MAC address of a connected station, because for the life of me I could not get this to work properly using Fern Wi-Fi. I entered this MAC address myself. So if that's a problem for you, just go back and look at the prior videos in this module to see how arrowdump-ng works. But basically, we've got the password. So now if we close out of this and go into the keys database, we can see that the password is now stored in our database. Now, if we want to keep this password the next time we load Fern, we need to click Save Changes. We also have the option of inserting a key manually for a station where the password, we already have it, or we could delete an existing key. So now let's take a look at the Toolbox button. We'll begin by clicking on the geolocatory tracker. And if we click on this, we get the unhelpful message telling us that this feature has been depreciated. In other words, it just doesn't work anymore. From what I've been able to determine, this feature used to make a handy real-world map with pins showing the locations of access points. That's a very nice feature, and I hope the designers consider bringing it back in the future. If we click on Wi-Fi attack options, we can see that we have the option to specify a specific MAC address to spoof. Again, with the stated disclaimer that I don't entirely trust any Mac changer program in Kali Linux, and you really want to test them carefully to make sure that they work correctly with your hardware before you put your trust in them. Remember that just because Mac Changer claims that your MAC address has been changed doesn't always mean that it doesn't snap right back the second you associate with an access point, so test it thoroughly. And we can also specify our capture file settings if we want Fern to store the captured handshake somewhere else. If we click on font settings, this is exactly what you think it is. And don't make the mistake I did earlier. If you click OK here to get out of this dialog box, the next time you load Fern, there will be no text anywhere on this screen. That's because it will switch Fern to font size 1, which is basically non-existent. So make sure that your font size is 7 or bigger, or you'll be stuck. Or you can just cancel out of this screen. So now we'll take a look at the last kind of selling point of Fern, at least back in the old days, the cookie hijacker. And this will take a moment or two to load. Here we go. So for this, I've plugged in the Ethernet connection to the router. So I'm going to select that now in the form of eth0. If we were connected to the router, that is to say we entered the password and we associated with it normally, we could use one of the Wi-Fi cards down here, but Ethernet is a lot faster for this sort of thing, which is already going to be a little bit slow and a little bit buggy. So now we need to give the default IP address of the router, the default gateway, which in this case is going to be 192.168.1.1. Your default gateway may vary, and we're going to start sniffing. And this is engaging a man-in-the-middle attack, which is intended to grab cookies that are being exchanged over the network. So I'm going to briefly go into my other little laptop here, and I'm going to click on some websites that I know to be insecure. And hopefully the cookies will be grabbed immediately. However, this doesn't always work quickly, and when you try this yourself on your own computer, you'll see just how much these sorts of attacks will slow down the connection of the target machine. In this case, I'm getting a lot of DNS probes failed before the website actually comes up, and that can be a giveaway to someone who's kind of savvy about these things that something odd is going on with the connection. Okay, we've captured our first cookie for the machine on the network that has .11 as the IP address at the end, so we click here. Oh, it's still loading, that's why. I'm going to give this just a second to finish. This just does not want to cooperate. So I'm going to grab a few more cookies before I stop the sniffing. These are just random websites I'm visiting on the computer that I'm using as a target for this man-in-the-middle attack. And what we're doing here is we're stealing these cookies in real time. Unfortunately, real time is very slow because man-in-the-middle attacks really slow down the network connection. Okay, that should be good enough. I'm going to click Stop Sniffing. And okay, let's see what we've got. So I visited two websites. Here's the British Museum. Here's the cookie we captured for it. Now, Cookie Hijacker used to be a lot more effective in the old days. It basically works like this. You connect to the access point that you just hacked. Select the interface that you're connected through, which, again, in my case was eth0 since I'm plugged into the router. and then you supply the default gateway. Then you click the Start Sniffing button. Once you do that, you start gathering cookies from any insecure websites that the other clients on the network visit. And we can right-click on the cookie and click Hijack Session if we wanted to. That will eventually open a web browser, whatever you happen to have as the default browser, and allows you to literally hijack the user's session. If they're logged into Facebook, you'll be logged into their Facebook as though you were sitting at their computer, but on your computer. But in reality, that just doesn't happen anymore. I mean, good luck finding any website that isn't HTTPS. The security has to be really poor for anything to show up here, and honestly, there are better ways of conducting man-in-the-middle attacks. Ettercap, Bettercap, Wireshark, SSL strip, just to name a few. When you try this on your own target machine, you'll also see just how much the internet connection of the target that you're using slows down. And that pretty much covers it. Fern Wi-Fi Cracker is just another way of doing what you've already been learning to do if you've been following this module's videos in order. But in my opinion, it isn't the better approach because its functionality tends to be very spotty, and because all you can do is a direct brute force attack, which, quite honestly, is the worst way to crack anything and should always be your last choice, because in reality, it's always going to take about 10,000 years unless the person is very, very dumb about their password. And another thing I have to mention, and I know it seems like I'm really, kind of ragging on Fern Wi-Fi Cracker, but when I ran this initially and tried to record the capture of these cookies, it not only crashed, it crashed the entire operating system, which I can honestly say has never happened before with any of these tools. So it is kind of spotty, but it can be a useful tool. As always, never use this or any other tool shown in these videos to hack anything that you don't personally own or have written permission from the owner to penetration test. I hope you found this video helpful.